Definition. Fx is continuous at x is equal to c if limit x tends to c minus of fx, or we call it left hand side limit, is equal to limit x tends to c plus of fx, or we call it right hand side limit, is equal to f of c. A function fx is continuous at x is equal to c if limit x tends to c minus of fx is equal to limit x tends to c plus of fx is equal to fc. Or in other words, the left hand side limit is equal to a right hand side limit is equal to value of the function at that point. Or we can say limit h tends to 0 of, or we can say limit h tends to 0 of f of c minus h is equal to limit h tends to 0 of f of c plus h is equal to fc. Then we say the function is continuous at x is equal to c. Now you can take an example. Fx is equal to absolute value of x by x at x is equal to 0. Continuity of the function at x is equal to 0. Now x is less than 0. Fx is equal to minus x by x, or is equal to minus 1. Therefore, limit x tends to 0 minus of fx is equal to minus 1. And limit x greater than 0, fx is equal to x by x, or is equal to 1. That is, limit x tends to 0 of 0 plus of fx is equal to 1. That means left hand side limit is not equal to right hand side limit. Therefore, function is, therefore fx is not continuous at x is equal to 2. Second example. Fx is equal to absolute value of x minus 2 at x is equal to 2. Discuss the continuity. Here, left hand side limit is equal to limit x tends to 2 minus of fx is equal to limit x tends to 2 of minus x plus 2 is equal to minus 2 plus 2 is equal to 0. That means the left hand side limit is equal to 0. Similarly, right hand side limit is equal to limit x tends to 2 plus of fx is equal to limit x tends to 2 plus of fx is equal to limit x tends to 2 of x minus 2 is equal to 2 minus 2 is equal to 0. And f of 0 is equal to, f of 2 is equal to, f of 2 is equal to absolute value of 2 minus 2 is equal to 0. Therefore, left hand side limit is equal to 0. Right hand side limit is equal to 0. Value of the function at x is equal to 2 is also equal to 0. Therefore, fx is continuous at x is equal to 2. Fx is equal to x plus 1 for x greater than 0 is equal to 2x minus 3 for x less than 0. x than or equal to 0. Discuss the continuity at x is equal to 0. Here, limit, left-hand side limit is equal to, left-hand side limit is equal to, limit x tends to 0 minus of fx is equal to, 0 minus means x less than 0 is equal to here. Therefore, it is equal to limit x tends to 0 of 2x minus 3. When x less than 0, the value of the function is equal to 2x minus 3 is equal to 0 minus 3 is equal to minus 3. And the right hand side limit is equal to limit x tends to 0 plus of fx is equal to limit x tends to 0 plus means x greater than 0. Therefore, is equal to limit x tends to 0 of x plus 1 is equal to 0 plus 1 is equal to 1. Left hand side limit not equal to right hand side limit. Therefore, fx is not continuous. Discuss the continuity of fx is equal to absolute value of x minus 2 plus absolute value of x plus 1 at x is equal to 2 and x is equal to minus 1. The function. We can divide this function into various forms. Is equal to fx is equal to when x less than minus 1. X less than minus 1, x minus 2 is negative. Therefore, this will become minus x plus 2. X less than minus 1, this is also negative. Therefore, it's equal to minus x minus 1 is equal to minus 2x plus 1. And when x greater than minus 1, that means minus 1 less than x less than 2. Minus 1, the value of x lies between minus 1 and 2. You get fx is equal to, fx is equal to, any value here, put x is equal to 0 here, minus 2 is negative, minus x plus 1, minus x plus 2, plus, any value here, this is positive, therefore is equal to x plus 1, therefore the value is equal to 3. And x greater than, this is positive as well as this is positive, therefore fx is equal to x minus 2 plus x plus 1 is equal to 2x minus 1. And you have to find the continuity of the function at x is equal to and x is equal to minus 1. First we consider x is equal to minus 1. That is, left hand side limit x tends to minus 1 minus of fx is equal to limit x tends to minus 1 minus is equal to limit x tends to minus 1 of less than minus 1, the function is minus 2x plus 1, minus 2x plus 1 is equal to minus 2 into minus 1 is equal to plus 2, 2 plus 1 is equal to 3. Minus 2 into minus 1 plus 1. Minus 2 into minus 1 plus 1. And limit x tends to minus 1 plus of fx is equal to limit x tends to minus 1 plus of fx is equal to. You can see here the value is equal to 3. Between minus 1 and 2 x, the value of fx is 3. Therefore, this is equal to 3. And f of minus 1 is also equal to 3. Therefore, fx is continuous at x is equal to 3. X is equal to minus 1. Continuous at x is equal to minus 1 because left hand side limit is equal to, right hand side limit is equal to value of the function at that point. All those values are equal to 3. Similarly, to find the continuity at x is equal to 2, limit x tends to 2 minus of fx is equal to, limit x tends to 2 minus of fx is equal to, see, 2 minus is less than 2, value is equal to 3, this is equal to 3. Limit x tends to 2 plus of fx is equal to, 2 plus means x greater than 2, the value is 2x minus 1, that's equal to limit x tends to 2 of 2x minus 1, that's equal to 4 minus 1 is equal to 3, and therefore 2 is also equal to 3. Therefore, fx is continuous at x is equal to